Hey guys, what's going on? So today we're going to be going over 4.6, isosceles and equilateral triangles, and some theorems based on properties of those types of triangles. So don't forget, for an isosceles triangle, you have these two congruent sides here, and directly across from those sides are the base angles, which are directly above the side that we call the base. So the base angle theorem states that if two sides of a triangle are congruent, then the base angles are congruent. So again, looking at this, the base angle theorem is stating that given that these two sides are congruent, we can then say that these base angles, or the angles that correspond to those sides, are congruent. So don't forget, angles and sides correspond to one another by being directly opposite uh, or directly across from one another. So this angle corresponds to this side. So again, base angle theorem, given that the two sides are congruent, you can then say the base angles are congruent. So in this diagram here, using the base angle theorem, again, it tells us these sides are congruent, therefore we can say these angles are congruent. So we can say that angle B is congruent to angle C. Okay, then going the other way around, or the fancy word in math we use for saying the other way around, the converse of the base angle theorem states that if two angles of a triangle are congruent, then the sides opposite are congruent. So this is going the other way around. On the base angle theorem, we were given that the sides are congruent and concluded that the base angles are congruent. Here we're just going the other way around. We're given that the base angles are congruent, therefore we're going to say that these sides are congruent. So side AB is congruent to side AC. Okay, so a corollary to the base angle theorem and converse theorem. Corollary just means you're still cool, but just not cool enough to be called a theorem. Typically means because the logic used in this is going to be the exact same logic from a theorem that was already stated. Not that any of that's that relevant, but it says if a triangle is equilateral, then it's equiangular. Because using the logic from the base angle theorem, we were basically stating that given that these sides are congruent, then the angles are congruent directly opposite of the sides. So here we're given that all the sides are congruent. Therefore, all of these angles are congruent. Kind of makes sense, checks out, all the sides are congruent, therefore all the angles are congruent. So that means if you're equilateral, you are then automatically equiangular. All your sides are equal, all your angles are equal. And don't forget, so if you are equiangular and you're a triangle, so all your sides and angles are equal, so we can actually then say if you're equiangular, we can tell you exactly what each angle is going to measure, because don't forget that all the interior angles in a triangle add up to 180, okay? And if all three angles are equal, split that up evenly into three pieces, that is 60 degrees. So if you're equilateral, you are equiangular, and each interior angle will be 60 degrees. So let's go ahead and look at some examples. So it says find each missing measure. So first side, first one it wants you to find is side EF. So side EF is right here. It is directly across from 23 degrees. We also have 23 degrees right here, and directly across from that is 18. Because these two angles are equal from the base angle theorem, we can then say these two sides are congruent. So long story short, this side is also 18 inches. Wants us to find measure angle F. Well, we have two of the angles and we're missing the third. So that's about as straightforward as it gets. We know all three of these angles should add up to be 180. So we can do 180 minus 23 plus 23, which is 46. So this goes to 134 degrees. Next, let's find the value of x. So it gives us that these two sides are congruent or equal. Okay, so translating that sentence from English to math, if these two sides are equal, then I will just set them equal to one another so I can solve for x. Okay, so I'll move my 2x over. Okay, and when I have a quadratic like this and it's set equal to 0, I can factor. So I need two numbers that multiply to be negative 24, add to be negative 2. Those numbers would be negative 6, 4. So I can rewrite this as x minus 6 times x plus 4 equals 0. So when it's written like this, this is your factored form. And don't forget from Algebra 1, you learned a property called the zero product rule, which essentially just states that, hey, x minus 6 and x plus 4, at the end of the day, those are just numbers. I don't really know what those numbers are yet, but this is just two numbers being multiplied by one another. And their product, or the result of their multiplication, is 0. That's only going to happen when one of the numbers or both of the numbers are 0. So this is all a very fancy way to say that given factored form and it's set equal to 0, we can take each factor and just set it equal to 0 in order to solve for x. Because again, if either one of those factors are 0, the product will be 0. So over here we get x equals 6. Over here we get x equals negative 4. And for the purposes of this class, we'll always take the positive solution. So x equals 6. Okay, lastly, example 3, we have triangle PQR is an equilateral triangle. Then it says solve for x, solve for y. Okay, so it's equilateral, so all these sides are equal, and that means therefore it's also equiangular. Okay, great. Let's start with y. To solve for y, we have each side given to us as an expression of y. It's equilateral, so we can just choose any two sides and set them equal to one another in order to solve for y. So I'm going to choose 9y plus 1, and I'm going to set it equal to 11y minus 23. Again, it doesn't matter which two sides you choose. Just pick two of them, whichever ones your heart desires, and solve for y. So now I'm going to subtract 9y, subtract 9y. Now I get 1 equals 2y minus 23. Add my 23 over, I get 24 equals 2y. Finally, divide by 2, I get y equals 12. So that's going to be my y. Okay, now to solve for x. Well, it's equilateral, therefore it's equiangular. Therefore, we know each interior angle will be 60 degrees. So take 7x minus 3, set it equal to 60. Now I get 7x equals 63. Divide by 7, I get x equals 9. And that's it for today. Thank you, guys.